another episode in our TimberTech decking series?
Absolutely.
Excellent. We could switch gears here and focus on the composite product, or a lot of times I use Capped-Composite just because grew up when it didn't have a cap and it was a true composite.
Right.
Yeah. A lot of staining, a lot more problems.
Yeah.
Glad we're at where we are today. First question, we could start off with just spacing requirements, gapping side to side on the boards.
Sure. As far as side to side, running the boards on edge, you're definitely going to want to leave a gap there. And we do make a fastening system that will actually set a spacing for you, but allowing for airflow, as we talked about with PVC, allowing for airflow for your framing, allowing for some runoff from the surface of the deck so water and debris can run off. But also with composite material, you do want some airflow around the product itself. So a little bit different from PVC.
Okay.
So yes, we do require a gap. You don't want to start off with these push tight together.
Okay. If for some reason the board was coming up close to the house or a deck post or bench post, I'm assuming there's a gapping requirement there as well.
There is. So the product won't really see any expansion and contraction width-wise, but your expansion and contraction will be pushed into the length. And if you're coming into a post at the end of the board or the house or a picture frame or other structure, you're going to have to allow for that expansion and contraction of the product and the length of it. So unlike PVC, where we can limit that expansion and contraction and pin it tight, this we have to allow for some of that movement.
Okay. So you're referring pretty much specifically like butt joints and or a miter joint. So,
correct. Or going into a solid structure, like you say, a post or the house.
So rule of thumb on that, it's temperature, a little bit temperature dependent on when you're actually building your deck?
Definitely. Right. So again, unlike PVC, where the bigger concern is the contraction, with composites, we don't want to always start tight. For example, if we start tight with a cold install, when the board heats up and it tries to expand, it has a lot more force. So it's actually going to push up against whatever structure or other board or whatever it is. It's going to push against it much harder. And you could potentially see the ends of the boards flaring where they push up. You could see it push out structures. So you do have to, depending on your temperature, you do have to start with a slight gap in it. Okay. And weather dependent, that gap may be a little bit smaller, a little bit wider. And I would definitely refer people back to our install guides to look at that guide to see exactly what, based on what their temperature is, what spacing they should start with.
Yeah, that's a great point, Pat. That's one of the main reasons we've done series like this, is just we've all seen those pictures, right, where they install it too tight. And then, like say, it's feeling like it's curving up a little bit, the joint, or like you said, flaring is a great word. I saw that in a picture at one point. Mm-hmm. Ties in great to the next topic, how to flat out eliminate butt joints, methods of doing that.
So a couple things you can do. You can do inlays, you can do divider boards, meaning if I have a long run of decking coming together, instead of actually butting them together and having a seam, I can run a opposing board running the length, the opposite direction, and bring in my two ends into the side of that. That eliminates or limits the size of that gap that could potentially open. So essentially we cut that gap in half by pushing it on either side of this center board. So picture framing would be another option. So eliminating butt joints completely by shrinking the infield of the deck. So if you have a 22-foot long deck, you could take a picture frame board running around the perimeter and do a single or a double picture frame and shrink the infield of the deck so you don't have a joint anymore.
Gotcha. And you're right. It's amazing how much better this scenario looks than this scenario. Sure. Usually by the time, somebody, So
there's additional blocking, additional framing that needs to be considered when doing something like that. But aesthetically, it does look much better.
Yeah. Okay. Maybe we switch gears to approved fastening methods for the Capped-Composite or the composite line. Okay. What can people do there?
So you can certainly fasten it from the top down. You can run screws through the face of the board. We have the plug system for this as well. So for most of the composite lines, we have the Cortex plug system, which allows you to drive a screw. The system will countersink the screw, and then there's a matching plug that can go into the hole and essentially cover up your fastener. Now, if you're doing that, there are a couple things to keep in mind, especially in composites. Number one, you have to pre-drill when you go into composites. If you're going to fasten from the top down, whether it's a screw or the Cortex system, you have to pre-drill.
Period.
Yes.
Okay.
Yes.
So somebody says, hey, our screws are self-drilling.
The problem with fastening through these boards is like they're so dense. The core has so much material that when you drive the screw into it, the material has nowhere to go. So it just gets forced out, and that creates pressure.
Sure.
That pressure will result in a split eventually. So taking the material out of the hole, drive your screw into the hole, and then making sure that you're using the right size bit to create the right size hole is important. So not just doing an 1/8 inch, just a pilot bit. You need to use the right size bit.
Interesting.
And then lastly is making sure, specifically if you're doing something like the Cortex system where you've driven a screw and you're left with a hole, that you put that plug in before you have a chance to get any water or moisture in the hole. If you wait a couple days and you come back and you've had morning dew or you've had slight rain get in that hole, the wood flour inside will now absorb the water, it'll swell, and that hole will now be smaller than what you've drilled it at. So now you're trying to jam the plug into a hole that's too small, and you're recreating that pressure effect again.
Wow. Can you talk about the fastening methods with respect to placement within near the end of a board and or the side of a board? You just mentioned cracking. Like I've seen some of that over time.
Sure.
What are those best practices?
Sure. So with composites, at the ends of the boards, we typically want you to stay back 3/4 of an inch. So we want you to hold some distance back. We want your fastener to be perpendicular, so we want straight down fastening. We don't want to toenail those fasteners back through the end to the end of the board.
Yeah.
And the typical scenario there would be that somebody may have their boards coming together at a butt joint over a joist, and they've left a small gap. But now they've pulled their screws back 3/4 of an inch, and at that point they're off the joist.
You can't even connect.
Right.
Yeah.
So they'll toenail. They'll angle their screws down and to catch the joist. That toenailing effect can crack the ends of the boards very easily.
Just start blowing it out and working its way up. Yeah.
Exactly.
Yeah.
So in that scenario, what we would tell you is if your joist is running this way, sister on a block at the position here, fasten one board 3/4 of an inch back down into the blocking, the other one 3/4 of an inch back down into your framing member, into your joist. So yeah, you definitely want to be cautious at the ends of the boards when you're fastening. If you follow those guides, really you shouldn't have any issues.
Yeah.
So,
And there again makes a great case for putting in divider boards.
correct.
And not having butt joints. You work on your design ahead of time.
Right.
I think people would be way happier for one.
Yeah.
Probably less work in the end too. Can you talk about this? Are there limitations of what kind of fasteners you can use with a scalloped bottom board?
Sure. So you can fasten through the face of this. You just need to really be aware of the legs of that board are and understand that you can't fasten through the part that's unsupported. So you need to go through the solid part of the board when you're doing top-down fastening, following the same recommendations as far as pre-drilling, spacing. We do now make the scallop bottom board would be, in the 4-sided cap would be what we call our terrain collection.
Okay.
We do make a terrain plus board. So this is a new product we've come out with this year. That board is actually a little thicker profile. Now that one, we do make the Cortex plug system for. And to use that, in the box of the Cortex, there will be a template, a guide that you put over the board, and it shows you exactly where to pre-drill. So you can line that up perfectly. You don't have to actually set it up yourself. To give you a little extra guidance on where those fasteners should go.
Pat, I know we've got some grooved boards here. Can you talk about approved clip system fastening options?
Sure. So we do make a metal fastening clip or a metal fastening option that is a clip that actually goes into the groove of the board. It's called a conceal lock system.
Might be this one. Huh?
Yeah.
Okay.
So the conceal lock is a stainless steel clip, and the clip itself actually has some prongs or teeth to it that will bite into the cap, and it'll hang on to the board a little bit tighter than just applying pressure, which most clip systems are really just pinching the board down to the joist. So this gives it a little extra hold, but even with conceal lock, understand that clips in general are designed still to let the composite material have a little bit of expansion and contraction and move through the clip. So even with this extra hold that we have, it's still possible that you can see that movement at the butt joint. So following the recommended spacing is still very important, even with the clip system.
Okay. I know when we were talking about PVC, you talked about trying to fasten intentionally at the end of runs. Anything like that, a recommendation here, or are you really just relying on the clip and proper spacing?
For this, we're really more relying on the clip. Again, with PVC, we were trying to hold it as tight as we could.
Okay.
With the composite material, we're again allowing it to have that expansion and contraction. We're just setting up ahead of time that we're going to make sure that we give it enough room to do that.
Okay. Well, another really good episode. It seems to me, and you mentioned it before, I think, if people take the time before you cut one board, fasten one board, read cover to cover the installation instruction for the specific brand and product line you bought, people will be much happier, get a better looking product, not void the warranty, so forth. So,
and we have a full customer service team that's ready to talk to anybody when it comes to installation. They're all well trained, and if they don't know the answer, they're going to get it for them.
Yeah, you're right. Yeah, appreciate it. Another fantastic episode. Thank you.